Hello everyone, welcome to Network Security Assignment Series. In this video we will see the overview of all the assignments that we will be doing in this semester, and also we will go through some important concepts. So what are doing in this semester is implementing the rate limiter using the token bucket algorithm, and we will use AI for the implementation. So we will discuss about the token bucket and rate limiter algorithm in detail when we are implementing the concept later in later assignments. But to give you a context, let me put these concepts in simpler terms so that you can know the scope of the assignments and what you will be doing throughout the semester. So you may ask why we use rate limiter and token bucket algorithm, but before that let me give you an example. So imagine you have a website which can handle 100 requests per minute, but suddenly a hacker tries to flood your website with 1000 requests per minute. So then when the hacker floods your website with 1000 requests, in normal scenarios, website which can handle only 100 requests per minute takes 10 minutes to complete those 1000 requests, and the genuine user who are trying to use the website is logged out of the website for 10 minutes until that all the requests are completed. So this is called depth attack, or in simpler terms we can call it denial of service attack. So we use the rate limiter and token bucket algorithm to prevent these denial of service attacks. Let me give you a simple explanation of this rate limiter and token bucket algorithm. So imagine you are in a game arcade and you want to play games at the arcade, but there are some rules that you need to follow when you are inside an arcade. So the rate limiter is the rules. So what is it? It's basically a set of rules on how fast you can do something, and then you can say why do we use this, so that you don't end up playing all games too fast. So it is basically designed to stop you from doing everything very fast. So you can see rate limiter algorithm in real life too, that is speed limits on road, that is like limiting you, and also you can see only one sample per customer. Whenever they give you samples, they only give you one sample. And also in X, which is formerly known as Twitter, you can only post 10 tweets per minute. For this is an example. And also in computers, you can similarly see this rate limiter, that is stops hackers from spamming your website. We have discussed this earlier, and prevents one person from using all the server power, and makes sure that everyone has fair share of the access. And next we have token bucket, that acts as like a ticket system. So now how can we enforce these rate limiter rules? We use tickets for that, that is tokens. So let me explain you with a simple example, that is we will be using cookies. So imagine you have a cookie jar, that is token bucket. So in that cookie jar you have 10 tokens or 10 cookies. You get 2 new cookies added every minute, and you can only eat one cookie at a time. So how it works? So initially let us consider that the jar is full, that is with 10 cookies, that is in terms of token bucket, the bucket is full. Now you want to play a game, that is eat a cookie. So you will check the jar for available cookies and take one cookie from it. Now you have 9 cookies left. Similarly, in the token bucket, when you send a request, it checks the token bucket and see if it has any tokens in it, and if it has tokens, then it will just use one token and then process your request and reduces the tokens from the token bucket. And again, imagine you want to eat a cookie again. Now again it one cookie is deducted from the jar. Similarly, this process goes on till you run out of cookie. But we have a condition here that we get 2 cookies every minute. So to empty 10 cookies you need 5 minutes, and every 2 minutes you get a new cookie. So here you need to wait some time till you have a cookie once you have exhausted all the existing cookies. So after waiting for some time, when the cookies arrive or appear again, you can just take it out and eat it. So similarly, in rate limiter algorithm, the token bucket algorithm, what happens is every time you request a similarly in a token bucket, every time you request, one token is taken out from the token bucket and then the request is processed. It is done till the token bucket is empty, and you need to wait till there are some tokens in the bucket for processing further requests. So this is like a quick overview of what a rate limiter and token bucket is. So before continuing next, let me just go back a step and discuss about why we are using AI. The main reason behind implementing our assignments using AI is the increased usage of AI in our day-to-day lives. We are using AI for like simple everyday tasks like writing an email to seeking assistance in complex code debugging. And as of today, AI is better than humans in writing code, but humans are far ahead in writing the logic, while the AI still struggles with writing the logic perfectly. So in this assignment, we will leverage the coding ability of AI with the logic building skills of us humans in creating a project that is functional. For that, we need a formal specification of the problem, and we do it by using a concept called design by contract. So let me now explain what design by contract is. Again, I will explain it with a simple example. Imagine you are in a store and buying a candy bar. So here you will make a contract. A contract is simply a promise between two people or two systems or programs on what they will do. An example for contract is like everyone rents an apartment. That is, the contract says I pay you rent, you give me space and keys for staying in the apartment for a fixed period of time that is mentioned in the contract. And another example we have is a job. So you work for 40 hours and you pay me some amount of money that is decided in the contract. And then we have one more example, that is pizza delivery. That is, when you order a pizza, you get it in 30 minutes and then you pay for it. And if the contract is violated, sometimes you may get free pizza depending on the contract. If someone breaks the promise, then the contract is violated, and of course someone is in trouble. So let us see this example. In the context of candy bar contract, you as a customer will pay $2 to the seller, and the seller in return gives you one candy bar. So the contract here is, if you give him $2, then he will give you candy and both parties are satisfied here. But what if someone breaks the contract? You try to pay $1 instead of $2. So the owner says this is no deal because the contract says $2. As a result, you won't get a candy. Or in other scenario, you pay the store $2, but he says here is your half candy, and you say no deal because you are paying for the full chocolate and you need to get full chocolate. As a result, you won't get your candy, and the store owner won't get their money. So, but when the contract is completely followed, you pay the shopkeeper $2 and you get your candy bar and everyone's happy. So that's how contract works. So now let us see how contract works in programming. Same idea but for code. Instead of people making promises here, functions make promises. So, and there are three types of promises. So the first one is precondition. That is what you must do before the code actually works. So in terms of the example that we have just seen, you must pay $2 before you get the candy. So similarly in code, you must input the program with some set number of value before it returns any value. For example, if you take a function that calculates square root, your precondition must be that you must give a number greater than 0. If you break this promise, then you won't get any result from it. And then we have the second promise, that is post condition. That is what the program returns you after it is done performing all the operations or the specified functions in the contract. So that is when you give it a positive integer. In this example, calculating square root, it returns you a positive result. If it breaks the promise, then there is a bug in the code that just returned the answer. And then we have third type of promise, that is called invariant. That is, these are rules that must be followed at all times, no matter what. So for example, let's take a bank account, and in bank account, balance should never be negative. That is, always the balance should be positive, and if it fails, then the whole system breaks. So this is the third promise we have, that is invariant. So this is the design by contract concept that we will be using in designing the project, and also we will be using the Google's anti-gravity for implementing the complete project. Now let us dive into assignment 1. So to complete the assignment, you are provided with some files. So you will be given all these files. So we have the main assignment document, which has like question and the steps you need to follow, and then we have a worksheet that you need to fill to get complete idea of the assignment. And then you have some more files. I'm using a Windows system, so I'm opening this .exe application. This is the rate limiter algorithm using token bucket that we have discussed earlier. So what you have to do is first go through the main document that we have given. First go through everything, each and every detail, and then once you have gone through everything, then you need to come here and see the functionality, like use all the buttons and see how everything is going on and what's happening here, and try to guess what's happening in the backend too. You can use the log also. And once you have explored this, what you have to do is go back to Assignment-1, the main Word document, and then try to solve these questions. And simultaneously you need to go to the observation worksheet, that is the second Word document that will be given, and try to fill everything in the given spaces and try to answer everything. If you have any doubt, you can just ask AI what's happening here, but don't depend on AI completely. So here some rules are mentioned and you can read it if you have any doubts. And similarly you need to complete everything, like what happens when you have clicked on single request. For example, let me show you. So when you click on send single request, you can see the token bucket is like partially emptied, and then it took some time to fill it back to the full capacity. You can see it here too, what happened. Similarly you can fill out the rest of the assignment. It is basically token bucket under different situations, like when a user submits a single request, and also when a hacker attacks the system with hundreds and thousands of requests at a time. And after you have completed this, you can just get complete idea of the project, and you can define a contract. That is you can define what in class invariants are. That is invariants are something that are like true throughout the system. In this case of our assignment, you can define them, and also similarly you need to design preconditions. You need to guess what preconditions are, and also post conditions. And then once you are done with this observation worksheet, you have one more task to do. That is you need to write 2 paragraphs about how you have completed this assignment and what's the role of AI in it. You need to answer all these questions, and then also need to complete this part, that is for every invariant, what did you observe, what happens if some invariant is wrong or violated. And then you need to submit all these files. And also you have some bonus points if you submit your AI conversation log, that is all the questions that you have asked regarding these assignments. And there is one more thing, this submission should be in video format. You need to upload a video of you explaining about this assignment, like what you have noticed regarding the design by contract, and also the AI conversation log, what the AI returned and what you have asked, and what is your overall opinion of these assignments. Please try to express it in your own terms and don't read it from these sections. And then we also have some details regarding assignment 2 in here. which we will see it in the next assignment. But that's it for assignment 1. Thank you.